Hackers, attackers, internal or external, you name them, all of them need an entry point to your systems and need authorized access to resources. These are controlled by what we call security controls. ESM resources, ESM stands for RACF, for External Security Manager, like RACF, Top Secret, ACF2, and the security control can be ESM resources, as we just named, palmlib settings, file settings, and so on, each of which is called an attack vector. Altogether, they create the attack surface. That's what attackers are using. As a sample of attack vector is the APF list, which is listed below on the screen. The APF list, which allows switching from problem mode to supervisor mode, is controlled in a way that can be used by an attack vector as an attack vector. Datasets in the list are not on the volume specified, does not exist, or any other misconfiguration issues. In order to configure our system, we are using CSM, or Configuration Setting Management. And configuration setting management is a method to define your assets and the required values that together creates a secure environment. The security environment minimizes the risk of existing attack surface. The process of configuration setting management is executed by visiting security controls, detecting the actual state or value, and compare it to the desired values, again, described in the CSM. The desired value is dictated by a standard or a best practice. The result is a list of tasks you need to perform in order to lock down your systems. And the security controls locking process is called hardening. There are predefined frameworks that defines the security controls and the defined settings or required settings. CS benchmark and STIG framework are fine examples for those. STIGs is the only framework that defines configuration setting management for legacy systems, mainly ZOS, and this is why we are presenting them in front of you. And this is why we will use them later in this presentation. Trade secret, etc. SBI, or as we call it, sensitive but unclassified level, usually indicate internal procedures used by federal agencies, which are not published public. Last level is public information that you can get from other resources like the internet. The combination of confidentiality and assurance levels create 9 different levels. When using STIG framework, you need to define the organization confidentiality level and align with the assurance levels related to them. So how we implement CSM today? Usually you don't. My experience is that most sites doesn't have the required skill set or the time to perform that. They may have commercial to perform STIG checks. However, these tools or services requires high level of mainframe knowledge. Assuming that you do implement CSM, the use of these tools requires computer resources to collect the information and save them into a database. Remember, these products are limited to a single image, so you should run them on each image separately, consuming CPU resources, saving into a database. Once the data is collected, an expert should generate and analyze the report. The bottom line is that manual assessments are lengthy, expensive, and tiring. The attributes of manual risk assessment, the length, expertise needed, human-intensive resources, and so on, leads to the fact that they are performed in annual cycles. Meanwhile, the systems are configured, contiguously changing, as a result of business requirement, new versions of products, other requirements that generated changes. This leads to a gap between the security control desired state and the actual state. In other words, most of the time, you're not in compliance. At the same time, the hackers are doing well. They have automated tools and the knowledge. Part of them are stolen from ethical companies and agencies. They have a motivation driven by terrorism, like homeland resources, or criminal. They're interested in the money or the data you store or you have. They are well funded by their senders. We call the way they perform attacks, the automated way, algo hack, as they're using algorithms developed by others to perform attacks. Much like the stock exchange that moved from manual trading to algo trade. You may see this move to automation in many other fields of life. At the same time, the target of attack, us, uses manual procedures to protect our organizations, like the product we mentioned before. It is an unfair challenge. The idea of STIG automation is not new. SCAP and ISCM are here from around the year 2000. NIST, the National Institute for Security and Technology, get into a conclusion that the then 3-year cycle of security assessment is not reasonable anymore. ICM is a concept they created that defines the need to investigate and monitor security controls in much more frequent way. The goal is to supply decision makers with accurate information as input to their decision-making process, and to make security overall status more visible, more clear, and up to date. The effect of ISCM CSM is dramatic. As ISCM reports at near real time on security defects, the stakeholders can respond much more quickly to the risk. As you can see from the graphs presented here, the frequency affects compliance.